but in the meantime, I will give a bit of an intro. So Josh is here with us today. He's a distinguished technologist at Contino. He's also a published author, which I think is bloody wicked. He's generally referred to at Contino as the break glass in case of emergency made human. He works with businesses all over Australia, helping them to digitally transform. He will also be taking some questions, and from what I hear, that signing of the book could be a possibility, guys. So Josh, are we good?
Hopefully.
Let's give it a red hot go. If you can, use that one so we can all hear you.
I mean, people can probably hear me. Oh, God. People can probably hear me anyway, so I'm generally loud. All right. Serverless testing, local considered harmful. So people may have heard me speak before, in which case you might have presumed this warning was coming. There's going to be a lot of strong opinions. They're hopefully loosely held. Your mileage may vary. I'm not saying I have all the answers, just most of them. So, we'll have to see how that goes, right? All right, the hero/villain for our story today is a friend of mine called Richard, who I worked with in the UK. He's drunk the cloud native Kool-Aid. As you can see, that is a suit he actually owns. So when I talk about cloud native, I'm not meaning this unholy Cambrian explosion of things that the CNCF has. Really, it's building for the cloud, not just on the cloud, right? That can mean Kubernetes, but I'd argue in most cases it probably not. But okay, so back to Richard, and we're gonna start, and I always try and start this way, so when people get bored of me speaking, hopefully they've got the takeaways to start. So we're gonna start with the 3 key takeaways. The first is that the testing pyramid that we've all held dear to our hearts for many, many years is a serverless anti-pattern in reality. Hopefully some of these are contentious. I'm hoping to, piss people off as we go. Again, it makes it more fun. Second, emulating the cloud is a recipe for disappointment. I will be ragging on localstack for about half this talk. Maybe not half, but you've got to go with me on this, and hopefully I can convince you to throw it in the bin tomorrow. And the last is testing doesn't stop when code hits production. Again, hopefully people agree with me on this, or they don't. Either way, hopefully you agree with me by the end. So there's already an intro on me, so I'll go very, very quick. So yeah, I'm a distinguished technologist at Contino, which is a ridiculous title. I work with enterprises. I've done world-first service architecture on AWS. I've done mainframes. I've done machine learning. I am a speaker, and I do have a few copies to give away. I can sign them if you want, but I feel really weird doing it. I'm an AWS ambassador, Hashi ambassador, all the kind of stuff. I'm a professional lab mouth. So I'm going to talk about functional testing today. When I say testing, that's what most people think. And there are so many other things you can and should be testing, but I have 45 minutes, so I'm going to focus, or try. Anyway, I generally ad-lib a lot, so we'll see how this goes. Why do we test? And I just realized I have that slide twice. Why do we test? Is it to prevent bugs? Yes and no. Kind of. I'm going to, apologies for this, but I'm going to go a little bit of complexity theory. So when we build systems, they are complex adaptive systems. It's a very long way of saying when we make changes, we don't really know what's going to happen. We have ideas, we have theories, but we can't know what's going to happen. And if you don't believe me or this is kind of new, I think we've all been through this. You're working on something, you get to daily stand-up the next day, and yeah, no, I found something new. It's kind of it's the problem and the fun of software development. It's emergent. You don't know what you're doing until you do it, which is why estimating, another one of my pain points, is pointless. And that's probably also going to piss some people off, which is fantastic. Going from complexity theory, so behaviors of systems, of complex adaptive systems, are an emergent property. You can try and control them, but effectively they happen not 100% by chance, but just because you build something doesn't mean you know what it's going to do. This also means that unintended behaviors are an emergent property because you don't know what's going to happen, which then means that bugs are an emergent property because bugs is effectively just a synonym for unintended behaviors. Bugs are inevitable. You're really not going to get around them. So if testing isn't about preventing bugs in their entirety. What are you actually trying to achieve? Really, for me, it's this. The value of the release you're trying to do, the value of the change you're trying to do is greater than the risk of doing the change. That's all you're trying to really do. You're trying to go, actually putting this change in production is more valuable than the potential risk impact. You can't be sure about this. This is all about confidence. You can never be 100% confident, even with an ego as big as mine. I can never be 100% confident that I've got it right. But really, fundamentally what we're trying to do is how cheaply can you be confident or sufficiently confident that the value of the release is more than the risk? And obviously risk can take many different factors in terms of you break production or unintended, or there's all the damage that comes from that in terms of financial and reputational, and maybe you get smacked across the head because you've released too many bugs into production. There's lots of different kinds of risk in there. Again, just stepping back to complexity theory one last time, I promise, I'll move on. When you look at complex area and then you get tester are these enabling constraints. They allow us to preserve certain behaviors of the system, but they're not guaranteed to exercise the entirety of the system. So you're not going to cover everything, but you're going to cover a lot. Google very eloquently put it like this. The Beyoncé rule, if you liked it, you should have put a CI test on it. Google have taken this idea to the extreme with the idea that anyone in the business can make pretty much any change to any system that they want. So upgrading a package, take the log4j thing that happened, right? Google can update that in their one giant monorepo. They are insane. But that can be done by security, and if your system breaks, it is your fault, not theirs. So it's changing where the accountability lies from the person that made the change to the person that owns the system. But fundamentally, Google has probably second to none testing culture, and it enables a lot of the stuff that they do. Again, when we build a system, we have a mental model of how we think the system works, and we have a software model, which is how the system actually works. And testing is an opportunity to refine our mental model to try and bring it closer to the software model. And the closer you are, the quicker you can develop, the less bugs you're going to introduce. This is kind of the basis around, when you onboard onto a new team, you have to understand what's going on, right? So as, you have to build these mental models over time, which is why you get the guys who've worked on a system for 20 years seem to know everything backwards and forwards, and the guy that's been there 2 months is like, what the hell is going on? A really common refrain that I see when people start on the serverless bit is they find that testing just feels really hard. It feels really hard for them to do. They're like, man, it doesn't work the way it used to. I'm starting to do a whole bunch of different things. It's not really working. Like, all of a sudden I need Docker Compose to run like 10 containers on my laptop and it's set on fire. That kind of stuff that you see happening around the track, right? The fundamental problem that all those serverless, Lambda functions and Cloud Run and Azure functions, and all that wonderful stuff, although it is technology, serverless as a whole is actually a mindset. It's not just about moving the technology, it's a new paradigm that comes with new ways of working. If you try and apply all the ways you used to do things in like a monolithic on-premise environment to a serverless environment, you can have a bad time, which is what a lot of people do. If you try and do cloud-native development with a pre-cloud testing approach, local dev setup is hellish. Working with some enterprises like, oh, someone's onboarding, cool, all right, well, it might have the laptop set ready to go in 2 weeks. It's like, that's a lot of time. I've worked on teams where we had people pushing to production within an hour of joining. If you get this stuff right, you can move so fast. Testing across multiple services is brittle. This is something people find when they go to microservices, like, oh my God, what is this? How do I get the same level of confidence? And really it comes down to the tests they write are either really hard, they're hard to be impactful because either they're very brittle and really hard to work with, or they're kind of tautological tests that are really not testing anything at all. And they kind of end up in this really weird space where they're like, I don't have any confidence that my system even works when I make a change. And coming back to this serverless as a mindset piece, there's kind of 3 core drivers that led to it, and they all have impacts on the way you test. So these are kind of wider macroeconomic things, but really this is what the cloud, to a large degree, has brought to IT and businesses. So IT, historically, and unfortunately still in some places, is seen as a cost center. You don't want it to be. You want to see it as the innovation center. With that comes a very different level of expectation. You are expected to produce value, not maintain costs, ideally. Generally, we're moving into monoliths to microservices. If you're going down a serverless path, you're going to end up doing microservices. There kind of is no way about it. If you're deploying one Lambda that's God that does everything, think again. And one of the more interesting bits, especially compared to an on-premise world, that it used to be long lead times. Oh, I need a new server setting up, okay. The best case is maybe it goes to the server team that goes and sets something up. The worst case is, oh, we were out of capacity, we're gonna go find a server, come back in 3 months, we might have something for you, right? It's really, really different nowadays. And just on that innovation center point, because if people know me, they know I never shut up about the DORA metrics, and I've managed to find a way to fit them in again. So the reality is that nowadays we actually have some statistically verified ways of looking at engineering performance, and it is not velocity. The idea is that you should be able to deliver change frequently, routinely. You don't break things very often, and when you do break things, it's quick to fix. Now, a lot of the time, people come back and go, well, okay, that's all right for the digital natives, the Googles, whatever, blah, blah, blah. The reality is nowadays it's 26% of businesses, 1 in 4. From the survey respondents, so obviously there's going to be a bias there, but you can even see over time, 7 to 2026. This is not about digital natives anymore. This is about table stakes. If you can't do this, you're really going to run into stuff. If you're not moving in this direction, you're really going to start to run into problems. All of a sudden, the business is going to be like, well, our competitor's innovating so much faster than us. IT, go faster. We've done safe. Now you can go faster, right? We've added more Scrum Masters. We're going to go faster. Not how it works at all. So now on the Monolith versus Microservices bit. The way it used to be was you used to have a simple arrangement of complex objects. You had virtual machines that did a hell of a lot, and not that many of them. Where it's kind of gone to now, especially in serverless applications, is it's a complex arrangement of simple objects. Everything is easier to reason about in isolation, but instead the complexity has actually moved. It's moved from within the service to the integrations between services. So now when you're trying to test the whole kit and caboodle on a monolith, and then you try and do the same in a Lambda function, you're not going to have a good time. Because what you're trying to do is get to the heart of the complexity, and the complexity is actually moved where it is. The test pyramid, everyone's familiar, surely. So this really starts to not apply anymore, because really a lot of that complexity that we used to kind of capture within the unit testing starting to move to integration testing. Spotify came up with this. It's better. I mean, all models are wrong, some are useful. It starts to actually point to the fact that actually integration testing, unfortunately, because there are caveats on speed, is starting to get the more important part to do. And really, when you look at this, there are conversations to be had about how complex, what are you actually trying to achieve? And this will speak to kind of the years I've spent working on AWS platforms. When you talk about this complex, when you look at Lambda functions, there are kind of 2 general types that I see. There is AWS Lambda is glue, because AWS haven't done something, so you write a Lambda function to do it for them, which is all the time. And really at this point, you're probably gonna have all integration tests and very little implementation detail tests, because your implementation detail really doesn't mean anything anymore, because if you take that code out of AWS, it's useless. So what, you don't have this nice pure domain you're trying to look after. It's about like, well, actually, all I'm trying to do is stitch 2 AWS services together. There is nothing reusable here. So really, all I need to do is integrate against AWS services. There's not really point trying to configure it so you can test something locally, because what is the point? And I'll get into more about how you can kind of test in AWS a little bit more natively as we go along. The kind of the more interesting one, personally, is with domain logic. We're actually trying to build like a system of some form that services uses, not just makes AWS go quicker. And at this point, you do end up with a mix of integration and implementation detail. One of the core things to do when you're doing serverless development is all the side effects. Now, if there's any functional programmers in the room, they'll be very used to talking about side effects as a concept. You want to keep your domain logic, like the business logic of what you're trying to do, that should be kept pure. If there's any Bodo calls or AWS SDK calls anyway in your business logic, you've got a problem. The business logic shouldn't know it's going into AWS or GCP or Azure or a Raspberry Pi you've got sitting on the desk. It really shouldn't know. At the point where you've made it so it doesn't know, now I can test locally, because it's just logic that's working. It doesn't understand about any external dependencies in any way. So for my domain logic, I can actually iterate on that very locally, very, very quickly. Then I can independently test that the drivers I've got that are interacting with the cloud vendor work as expected, and then some end-to-end tests to stitch it together. this forces you to structure your code in a particular way. I didn't have enough time to kind of go into a lot of depth with it today, but if you go look at clean architecture, there's a book floating around there. If you go have a look at the way they structure code, that's generally how we do it nowadays. Been doing it for a few years. It's worked very well for this. Potentially, how I go on time, and I know I'm stopping everyone from lunch. I might have a chance to show an example, but we'll see how we go. One of these things is when you get to this point, this is a make file that I use. There's a Three Musketeers pattern we use at Contino, which I'm a big proponent of. Effectively, you abstract all your repos with make files to make it wonderful. This is an internal project, the make file from an internal project, and I abstract it a little bit and taken some stuff out. But when you look at testing and kind of setting up local development, there's no Docker nonsense in here. There's no setting up databases. There's no orchestrating a million dependencies locally to do things. And I have split my tests up into integration and not integration. So I can very easily run my local tests that will run really fast and check all my domain logic works. And then I can run integration tests and separation. And then for CI, I've got to test everything and report coverage, right? Because when you structure the tests like that to get coverage, you kind of need both running. And I've got some end-to-end stuff that I did with BDD and Behave in this example. But really, I always shudder to think when I see what level of complexity people take on to try and get their testing apparatus set up. Like, okay, now I've got to run Docker, I've got to run localstack. Oh, I have to kind of actually get on top of the AWS SDK that I'm using to make sure it's actually pointing to the localstack APIs. Okay, all of a sudden it's like, well, it worked on my machine. Yeah, who cares? Like, that's not a valuable thing. You want to be I want it to work in AWS. I want to be confident that it works. And really, the amount of confidence you can get locally is pretty low when it comes down to it. This is a really interesting one I find in serverless, because I've done it, and it's quite a cool thing to do. Like the testing heuristic. Like if you kept all your tests, but deleted all the code, how confident are you that if you wrote new code, it would work? Would you feel confident running that to production? Yes or no? I've gone through the point of actually deleting functions because I hated the way I wrote it initially and rewrote it and pushed that to production. With sufficient testing, like this is the best heuristic I found in the case of like, okay, well, how do I know that my tests are sufficient? And this is the best thing. Like if you lose your code today, but you got your testing there, you should be able to get close back to production quality very, very, very quickly. Local stack. I've already mentioned it more times than I planned to, but now I'm going to mention it a whole bunch more. AWS I can run locally. I am saved. Now, I've done projects with localstack. I've done a lot with it, to be honest, in the past. It's just not how to do things in the cloud-native sense. Yes, you can emulate AWS locally, but why? What actually leads us down the path of test doubles? Because generally in the past it was, yeah, add a test double, add a mock, add a fake, add a stub, run some kind of slimmed down system that kind of responds like the real thing. And they're fundamentally for when orchestrating the dependency is too expensive. Now, what classifies as expensive in here can be the amount of time it takes to substantiate. Maybe it has a high running cost. Maybe you have to talk with other teams to set them up. Like obviously, if you've got a SAP install or something like that, you can't just run up a new SAP install to test against. That's not a realistic thing to do. And I'll talk about some strategies you can use for that as we go on a little bit. But generally in serverless, like, yeah, you're trying to show that actually managing the dependency is more expensive than the test double. Therefore, the test double is worth having. But when you get to serverless, all those things that kind of drove the dependency costs are no longer true. Hard to configure. You've got infrastructure as code. Running up a Dynamo table is 20 seconds. Like, it's not that hard to actually configure anymore. High running costs. Most serverless stuff is completely pay-per-use. If you're using it for testing and just leave it alone, it will cost cents a month. Right? When you contrast and compare this about how much a developer costs a day, and I normally use kind of a benchmark of roughly $1,000 a day, any time, like if my developer has to spend 2 minutes on this every day, it's more expensive than just running all the stuff, leaving all the stuff running. And generally in serverless, if you're doing it correctly with autonomous teams and everything else, you don't generally have dependencies on other teams. You have empowered teams who are able to take control of this for themselves. We all know that handoffs are where productivity goes to die. Generally, if you find the empowered teams thing really hard to do, no technology is going to save you. You need to revisit how you've actually structured the organization. Just one of those things. So one of the common refrains, and I even get this internally, and I've had this debate so many times, which is one of the reasons for writing this talk, because I got sick of writing the same thing in Slack every week. People always like, oh, but then I want to run a local test, and oh, it takes a while to stand up the infrastructure, and I don't want to do that every time I run my tests. I said, who said that you're standing up the infrastructure every single time you run your test suite? That's insane. Why would you do that? This is just some Python code that I've used, and I don't want to think how many repos now, that effectively just jumps in and runs Terraform init, Terraform approve, Terraform apply, and Terraform destroy. What you'll notice is there is a environment variable escape hatch that if I set that environment variable to local, I can just stand up the Terraform once outside of my test suite, and it will be long-lived. It's not going to get automatically torn down, so I can live stuff up for the whole day and then pull it down at the end of the day. So then when I'm actually running these tests, my data layer and all that kind of stuff is long-lived. So I'm not having to wait every time for Terraform or CloudFormation or what have you to do things. Instead, for CI, it defaults to running new stuff up. And CI, you want under 10 minutes. Don't overly stress about my CI job took more than 2 minutes, now I'm losing productivity. It's not a worthwhile optimization, kind of beyond 10. That seems to be the general rule of thumb. And generally with Terraform and CloudFormation, most stuff you can rig up in 2 minutes and then have all your tests run on top. This was often an example that, something I did for a client back in the UK with AWS config, because some AWS stuff, like DynamoDB, you can build up, it's yours, you can deal with it. Something like AWS config, and this is again kind of working at the platform level, I was trying to build a Lambda function that aggregated certain config rules across the entire organization, reported kind of a classification of resources. Now, AWS config will give me different responses every single day because people change things, and I can't control that. I can't tell everyone, no, stop, you can't deploy resources because I need to test my thing. So this kind of comes from the React testing house of snapshot testing. So people have done, have unfortunately had to do front-end work, which I honestly hate. Then you will come across snapshot testing in here. Within Python, there's a library called Placebo that allows you to effectively, you call AWS once, and it stores the response. So next time you run your test, it replays that response back to you. This is higher fidelity than localstack because it's actually coming from AWS. And it allows you to actually test things properly. So I can, verify that my function running actually does, it does give me the right responses. And has anyone ever configured localstack with a Python helper? Because it's about 5 times more code than that, just to make it work. This is really, really simple. They get committed to Git. Everyone's working from the same thing. Really, really, really simple to do. If you can't if you can't orchestrate the dependency properly, then you can just capture the responses. You can refresh it occasionally, but don't change your code and try and do the refresh at the same time. It's one or the other. There are better things. There are more cloud-native things. There are things far more in line with what we want to do. AWS themselves have released SAM Accelerate. Serverless Framework has a similar thing, where instead, as you make code changes, they are live-streamed into AWS. You get full fidelity testing at speed, and you get true cloud-native testing. When you kind of get down to it, and as you actually properly secure your cloud environments, and you actually have production-like infrastructure, running as you in the account will not allow you to test anymore, because data should be locked away. KMS keys, you should not have access. I'll make the point that generally most environments are not set up to this level, but they should be. But fundamentally, you want to be actually assuming the principle of the Lambda function or equivalent when you're actually doing this testing, because it actually tells you what's actually going to happen. You'd actually, if you try and do all this local stack testing, or even just testing locally against AWS APIs or GCP APIs or what have you, if your security matures to a certain point, it's all going to break. And it should break. Because the reality is you should be testing against production-like infrastructure. Production-like infrastructure shouldn't be allowing you to get into all the databases and pull stuff out as willy-nilly to check things have gone where they should go, right? So coming back to this refinement piece that I talked about before, when you're testing against local stack, you are testing how your system works in local stack, and you're bringing your mental model closer in tune with that, not actually with where it's actually going to be running in production. For example, and localstack fixed this ages ago, but when I was using it, I found that the DynamoDB types were a lot looser. So what was working in localstack, when I went to AWS, was being rejected by the API. Now, that in and of itself maybe lost me 10 minutes of time. but 10 minutes of time multiplied by the amount of devs hitting all these random little edge cases and all those kind of things doesn't really work. And also when you start to look at localstack, yeah, kind of the basics are there. And you've got like the services enough to wet your whistle. You can get in like, okay, Lambda's there, Dynamo's there, cool, I can start working. Now I want to I have X-Ray in there and I have a whole bunch of other things in here. Localstack, like, cool, pay us. No, what? This was all about saving costs against AWS. What are you telling me I now have to pay a license for every single developer? Are you insane? And fundamentally, these AWS costs are so minuscule. Like, your local stack cost is going to massively outweigh your cloud bill. And this is insane. It's kind of on the last kind of rant I'm going to go on. Again, comes from people, and it's not that these approaches were wrong at the time. They came from a certain time, certain place, certain paradigm, and certain ways of working, and they made a lot of sense. The point is that when you go to serverless, that you need to reevaluate how you do things. One of these things is, I mean, I've hardly ever used a debugger. I'm really bad with them, but a lot of the time people get used to being able to attach a debugger to their running code so they can look at all the variables as they're going and all that kind of stuff. And then they get to this point, like, how do I attach my debugger to the Lambda functions? You can't. People used to do what seems in retrospect insane, where they'd like go onto a production system, attach a debugger to a running Java process to have a look at what's going on. In my mind, that's insane, but I can also understand why they did it at the time. But nowadays, that's not an option, and you shouldn't be annoyed that's not an option, but some people do get annoyed. This is just an absolute classic meme within the space, right? The thing is, it used to be lauded at as being ridiculous, when in reality, it's actually the case of how you should be doing things for a large part. We always come out with the adage that, code is read 10 more times than it's written. The reality is it's run in production thousands to millions of times for every time it's written for any code that's doing a lot of stuff. So really, where you need to focus your efforts is in how do I understand when stuff breaks in production, more so than how do I fix stuff locally. One of the things that I do a lot with teams is beginning with the end in mind. And this is trying to bring SRE principles in, just kind of service level objectives, not the other 6. But just looking at how can I use service level objectives to define what I'm doing. You kind of got, whenever you're kind of developing anything, really, and these are 2 questions that for every single feature should be asked, is how will I know my feature is broken? And that gives you your mean time to identification. And how will I determine why it's broken? Which is your mean time to recovery. If on every pull request review, if you're not asking these questions, you're going to end up pushing code which isn't operationally sound. Maybe functionally correct, but when it blows up, you're going to be really sorry at the end, right? For me, you should be looking at this one first. Before you actually develop the feature, you should be building the apparatus that allows you to understand your feature is broken. And then second, you can determine why it's broken. So SLAs, I talk about these way too much, but for anyone that's not familiar, service level SLIs, service level indicators, defines your success and failure. So for the feature, how can I measure that it was successful or it failed in production? What does that actually look like? Service level objective then defines what an acceptable failure frequency is. So, for every 1,000 requests, one's allowed to fail. Something like that, expressed as percentages. I'm sure you've kind of all seen SLAs floating around. And then an SLA is a contractual obligation, defines a penalty for every time you actually fall underneath that failure goal. Reality, most systems, you can just stop at SLOs, especially for internal systems. One thing I'm going to get into here, which is just something that always shits me, is an SLO written in Confluence doesn't mean anything at all. I call them Schrodinger's SLOs because no one knows whether it's alive or dead. I hate how often I see systems where people don't know whether the system's alive or dead. They're just kind of hoping it is. Not going to say anything about putting them in a box with poison and waiting for a timer. One thing that we've done, and this is going open source, this is not a sales pitch, please don't take it as one, was we built at Contino, I built this for a client in the UK, a way of dashboarding things in AWS that was SLO focused, that we kept it's all serverless, all very extensible. But this, when on the team I built this with, the first thing we did for every new feature was add it to the SLO dashboard before we started working on the feature. You can see some at the bottom around patching, compliance testing, and backups and stuff like that. I built, the backups was one I did just before I left, where we were rolling out a new backup solution. So the first thing I did was roll out, and this was where the config bit came in as well, the ability to understand how many instances are currently outside of backup plans, how many don't have active backups, with the idea that as I build the backup solution and roll it out, and this is across 500 AWS accounts, so you can understand why I'm trying to track these numbers, because you can't possibly hold that in your head. But I wanted to be able to show, as we roll it out, that these numbers going down. Because otherwise, you roll out a backup solution, and this is a classic thing. We built the tool. Is anyone using the tool? I don't know. Okay, why do you build it? And really, fundamentally, when you're doing this cloud-native development and talking about testing and getting into debugging, you should be trying to debug your development with the same tools you're going to use to debug it in production. Because otherwise, and this is another rant of mine, debug logs, why do they exist? Why do they ever get committed to mainline? Because you get them in production, you're like, oh, I'll be able to figure this out if I had the debug logs. Great, what are you going to do about it now? If you wrote these logs to understand things in development, you should be turning them on in production as well. Yeah, it's just a rant of mine. Because again, going back in time, you used to be able to switch on debug logs by changing an environment variable or something like that. You can't really do that anymore, and even if you can, like, transient issues that you see that have disappeared and you really wish you had that log data, oh, it's gone. Oh, well, too bad, right? Really, you get down to it and you end up with, be able to use X-Ray and CloudWatch, Grafana, Prometheus, all these kind of tools in production, and Cloud Operations Suite and Azure Logic Monitor. You apply the tools, synonyms for whatever cloud you use. But really, if you can't use these to figure out why your development's not working, how are you going to use them to figure out that production's not working? Debugger and local tools and that kind of stuff, you're not going to have them when you really need them. So why are you focusing on becoming really strong with them? Like when you look at Honeycomb and observability, which I suggest everyone do, they instrument everything and they use Honeycomb for all their kind of needs. It allows you to actually just, your code's going to be running in production for much longer than it takes you to write it. You should be focusing on that. And when you get good with the production tools, they're not going to slow down your development cycles by using these things. But it makes a lot more sense than trying to use a debugger locally and then getting stuck in production. So I'm actually running ahead of time, which is nice, unusual for me, and I know I'm keeping everyone from lunch, so, go figure. But I just wanted to kind of revisit back on the 3 key lessons. The one, testing period, is anti-pattern. There's the testing honeycomb that Spotify have. It's better. I still think, as an industry, we can do better than that. Emulating cloud is a recipe for disappointment. I hope any of you that are using localstack or equivalents today, maybe I might get lucky and some of you might revisit that decision next week. I understand that it's investment and everything else, and we're going to change the way we test, makes a product owner cry because they're not getting any features, but you need that time to actually invest in, paying down tech debt. And to be honest, if you're using localstack, I would classify that as technical debt nowadays. And last is testing doesn't stop when code hits production. You really, that's where you should be focusing for, because that's where your code delivers value and where breaking actually becomes a problem. So fundamentally look at what tools are in the cloud that you can use to understand your production code, use those for your development code at the same time. That was all I had, so hopefully there's some questions.
Like yet? Yes, I am. Have we got any questions? First of all, Josh, I love your brutally honest approach. It is fantastic. It's very real. I just wanted to throw that out there. Questions? Anyone hand up? Oh, sorry.
Sorry. Yeah, so I guess if you need to keep CI tests fast, that requires that you're able to kind of spin up an ephemeral stack and then tear it down in a matter of minutes. Like, what patterns would you use when you have like a hybrid architecture where you kind of necessarily have 1 or 2 serverful resources, say AWS Elasticsearch, for example?
Yeah, at that point, you've got to make like a trade-off at some point for going, well, the cost of keeping it running versus the time saving. You should be able to kind of, when I come back to that kind of $1,000 a day, you can run the data and go, it's going to be more effective to do it one way or the other. But I think it would be try and get the data together to go, running Elasticsearch is going to cost us this much if we just leave it on. okay, well, is that worth the speed up in development time for that? Like, it comes down to, you've got to make trade-offs. You just want to make the cheapest trade-off, whatever that is. But yeah, Elasticsearch is a pain. And it's expensive as well, so it's a hard one. And in that case, you might want to actually eat the CI run, or generally have some kind of mocked version of Elasticsearch. I'm not saying you can't mock, I'm just saying don't default to it. If it's going to be cheaper and you're going to get the fidelity you want, then mock away, but just, it should be not the default position, it should be, the other ones are too expensive, we need to go down this path.
Fantastic. Next one. Alrighty, hecklers in the front audience. Now, I am told you are here to heckle. So, have we got any heckling? No. Right. All right, guys.
So disappointing.
Looks like I'm going to get all the books. So, joking. Seriously, if we've got any questions, guys, please put your hand up. Fantastic. Thank you.
What's your opinion on sort of Docker versus Lambda? So, running native Lambdas versus running Docker containers or Docker serverless, or
I mean, with contain,
it's another level of abstraction, but it's also another level of testability.
Yeah, I like Docker, using Docker images, Docker containers for local development to try and get some standardization on environments. But if you're throwing them into production, be aware that you're accepting a higher level of accountability when it comes to your security posture, in terms of managing the containers, fixing vulnerabilities, all that kind of stuff. Like, when you're when you're running Lambda without containers, AWS fix stuff for you underneath. If you've got a container strategy and everything else, and you've got all that kind of stuff in-house, because maybe you've got some Kubernetes somewhere else and whatever, and you can kind of piggyback on that. But I still generally try and go with native Lambda where possible, because it's less work for me to do from a security perspective. Operationally, it's not fantastically different, but still, Docker, you're pulling extra packages that you have to rotate and fix the CVEs for. I think Sheldon had one.
Awesome.
One repo, one function. Put them all in a monorepo.
Monorepo. One function, one repo would just, my God, you'd hit your GitHub limits in about a week. Like, I always think start with monorepo because it's easier. And you can wait till you hit a scaling point. You're like, actually, multi-repo work for us. Like, normally when I've started a multi-repo before, and it's like, okay, well, now we need to share this kind of package of types around between the repos. Now we've got to figure all that out. And it's like, now we've got to push a dependency out. We've got to pull dependency version. Dependencies like, oh, what's the value in doing this? Oh, we have multiple repos. Yeah, but what's the value of multiple repos? Like, if you're working in vertical slices and you have your code set up properly, that you shouldn't be hitting like merge conflicts all the time or anything like that. And at least it keeps your code more consistent more easily. I've kind of gone back and forth on this over the years, but at the moment I just go monorepo until I feel the pain. Especially if you do clean architecture, like you end up with one code base that you kind of change the entry points for to do different Lambda functions. So you end up with just kind of one blob of code that you deploy in different kind of configurations to do things, which is generally a lot easier from a packaging point of view. It makes stuff a lot simpler.
Well done, because I didn't know what you were going to answer to my why, because I am not sure what a monorepo is, if I'm honest, guys. So sorry for throwing you a little bit for six there.
No, go for it.
Down the back, give me a sec.
Hey, Sam.
Have you applied these techniques in a Kubernetes environment?
Yeah, I mean, it's not fundamentally all that different. It depends on how much managed services you're running and all that kind of stuff, but effectively I think the patterns still apply. Like when I did some work for one of the mining companies in town a few years ago, and we built it and we deployed it into Lambda and ECS from the same code base. We just had to change stuff on the edge, and it was the same approach for both. There's nothing, like effectively, your code to a large degree really shouldn't understand where the hell it's being deployed. And you should be trying to take those changes and push them right out to the far edge of your code. Again, clean architecture helps a lot with this, but yeah, running in Kubernetes or not, the same principles I think still apply of just try and use the cloud as much as possible and stop trying to run like a Postgres database locally or whatever. Like you shouldn't need to. I mean, Postgres is a little bit different because it's such a standard, like stable platform that the emulation is generally very, very high fidelity, but still like, you know, try and figure out what you can do cheapest. And generally, developer time is the big one for cheap. Family Zone, I know sometimes you guys have different ideas on that, but for most of us, it's developer time. You guys have scale problems that all of us wish we had, so it changes the needle sometimes.
Alrighty, we can probably fit one more question in if we have it. Awesome. Thanks, guys.
Do you kind of have any thoughts on what might be good kinds of production tests to do and maybe sort of organisational pushback on doing that kind of thing?
I mean, yeah, organizations really always push back on testing. I think it is that I really like the service level objective stuff. I really like being able to understand how my feature is supposed to be working, how I'm going to track how that feature is working, and having just that really quick feedback that I can see I'm burning error budgets so something's gone wrong. I do think the SRE, looking at SRE for how to run stuff in production is probably the way to go, but I would say that's SRE as in like the Google books, not what a lot of vendors sell today, because I've had so many arguments on redefining it at enterprises where GSI's got in first, and they're like, oh, and it's rebadged ITIL build and run. That's not what SRE is. I think in production it's pretty much like, how do I know something's broken is the big thing. And service level objectives are probably the kind of the becoming dominant way of doing that. Like there is the classic monitoring of my CPU's spiking, send an alert, and it's like, no, you need the kind of business impact level metrics to understand that customers are being impacted because you measure from the customer. And then CPU spiking, useful diagnostic metric when you're in kind of debug mode, but you shouldn't be alerting on that. You should be alerting on, we're hitting so many 500 responses are spiking, something's gone wrong on our API, cool, let's go and fix that. Again, observability in Honeycomb is the big kind of, I think it's the big paradigm shift that's coming. Where you've got like high cardinality events. Again, I definitely do not have time to get into that in any great detail, but I can afterwards if you'd like. I'm more than happy to.
100%. Look, guys, that's probably time, Josh, but a big round of applause. That was unreal. Now, just a few friendly reminders. Lunch will be immediately served once you leave this door. Now, you can go the north or the south, or you can just duck over in front of the theatre room. There's going to be food sort of everywhere, basically, from what I'm reading here. Lunchtime sessions will commence at 2:35 in the theatre. That's definitely a typo, at 1:35 in the theatre, and both the river rooms. Note, do not do what I did before and eat your apple because you will get in trouble in there. Attendees, there will also be breakout sessions that will commence again at 2:15. Definitely 2:15. And I've got one in here with a wonderful, wonderful lady, and she will be talking about standing on the standing on the shoulder of giants, the next great generation in Technitu. So on that note, thank you again, Josh. Thank you, hecklers and everybody. Have a great lunch.